Okay, so I want to go through, some more examples here of the chain rule. And again, we're looking for grouping symbols. And so parentheses, trig functions, square roots make really good grouping symbols. Obviously, then there are other functions we're going to look at next week, like logarithms, exponential functions, things like that. But I see a square root, so that again is a good indication that there's going to need to be a chain rule. And so I'll go ahead and get our nice little blocker here. So I'm going to think about like blocking that out. Oh, a little too big. So I'm going to think of, sorry. Go back here, blocking that out. There we go. What if I just do this and drag it over there? Okay. So I need to figure out, well, what's the derivative of a square root? So remember, square roots, the derivative of square roots, think about this as the 1/2 power. So another way to think about this is something to the 1/2 power. So its derivative is like 1/2 that thing to the -1/2 power. Or since I know that square roots are the -1/2 power in the denominator, it's 1/2 square root of that thing. That would be the derivative of any square root. And then you say, okay, well, what was that thing? What needs to sit below there? Then that's where you could write your x squared plus 7x. So again, you can't change the identity. You can't take a derivative inside that square root because that's a fixed function. Something's embedded in that as a composition. But then immediately afterwards, you can multiply by the derivative of that inner function, which is quantity 2x plus 7. And, you might want to just kind of organize your work here. I would just put that up in the numerator. So there's your 2x plus 7. Here's your denominator, 2 square root of x squared plus 7x. So, there's your function. And again, you think about these compositions, you're creating more complex functions to start with. And those complex functions will have a lot more of changing peaks and troughs and curvatures. And the thing that measures all of those instantaneous rates of change also has to be, that complicated or complex to measure all those changes. So that's our derivative, a lot more, complicated than the original function. Okay, now number 6 is awesome because not only is there one chain rule. Can I clone that? I don't know. Yes, can I? It's so small. Clone. There are 2 chain rules, right? But sorry, awkward moments in video here. But just when you thought that wasn't good enough, not only is it a double chain rule, you also have a product rule, right? Think about that for a second. Let's go blue here for a second. You've got a sine function times a cosine function. So we have to make sure that we're obeying the structure of a product rule, but then within that product rule, we do derivatives of the inner functions, which would be chains. So let's go ahead. I'll go to red here and pick that thinner marker. Okay, so the derivative of sine. So the derivative of sine is cosine of that thing. And what was that thing? That thing was 3 theta. So I'm going to put a 3 theta here and immediately multiply by 3 because that's the derivative. But now the product rule says do one function, leave the other function alone. So I'm going to leave cosine of this thing alone. And that thing was 6 theta, right? Cosine of 6 theta. But realize, that I don't need a chain because I never did the derivative of cosine. I'm just leaving it. Remember, product rule says take turns. Do the derivative of one, leave the other alone. So this part right here does not need a chain. Plus, now leave sine alone. So sine of 3 theta stays alone. No chain rule because, again, we're not doing the derivative of that part. But then now, derivative of cosine, which is negative sine of that thing. And again, what was that? What was that thing? Grab that black dot. That thing was 6 theta. So that goes there. Oops. Got change that. So that's 6 theta. And then because that's an inner function, the derivative of 6 theta, which is 6. So like within the structure of product rule, you're only doing one derivative at a time. So if you're only doing one derivative at a time and you're not doing the derivative of the other thing doesn't need the chain. So then let's go ahead and simplify. I probably pull this 3 in front. So 3 cosine of 3 theta times cosine of 6 theta. Probably should put parentheses there. And then this negative and the 6 I'll factor out, so minus 6. And then sine of 3 theta, sine of 6 theta. So again, just be cognizant of that when you're doing product rule. The overall structure is still product rule, but then within that algorithm, there are 2 different times when you're doing derivatives. Each of those needs the chain rule, but not the other time. And I can make a similar analogy when I do quotient rule. When you do low, D high, only when you do the D high is there a chain rule. Minus high, D low, only when you do the D low do you need a chain rule. And then low, low, there are no derivatives, so you don't need any chains. Okay, so the next set of 3 examples I think I'll go ahead and do on this video as well, because again, it's applying the technique of chain rule, but not letting you get bogged down necessarily in all of the derivative algebra. So I see this a lot on multiple choice questions. So it says so here's a table of values like f prime, g prime. And it says, suppose h of x is g of f of x. Find the following, find h prime of g or 0. Okay, so here's the thing that that this is still like a composition. So f of x is my inner function. So if I want to find, the derivative of this expression, right? It says find h prime. So I'm going to do the derivative of the outer function first, which is g prime of that thing. What is that thing? Oh, well, that thing, there it is. Oh, nope, trying to just grab that dot. Why doesn't it, come on. Sorry, awkward. There it is. So like 30 seconds later, what is that thing? Oh, it's f of x, which means f of x has to stay the same. But then immediately you multiply by f prime of x. So the derivative is on the outside, not the inside. So then we use our table of values. Okay, so we're trying to find 0. So it's g prime of f of 0 times f prime of 0. So then what was f of 0? So f of 0, that's 2. So that goes there. So it's g prime of 2 times, and what was f prime of 0? Aha, negative 1. And then we can evaluate g prime of 2. G prime of 2 is 6. So this is the 6, this is negative 1, so we get negative 6. So it's basically, we're assessing the structure of chain rule, but not having to, again, have to simplify algebra because you know the specific values. Okay, I mean, you could pause the video and try 8 if you want, or follow along. Okay, so again, I might grab this dot over here. It says f of g of x. So initially, I'm going to do the outer function. So I'm going to do f prime of that thing. And then I'm going to try to pull that dot. Come on. I don't know. Oh, there it is. That thing goes here. So what was that thing? That was g of x. But then afterwards, you multiply by the derivative, g prime. And so then again, we fill in our missing pieces. So it's 2. So it's f prime of 2. And then times g prime of 2. I'm sorry, I made a mistake there. Let me go back. It's f prime of g of 2 times g prime of 2. And so then we go back up and look at 2. So g of 2 is 1. G prime of 2 is 6. So g of 2 is 1. So that's still embedded in f prime. G prime of 2 is 6. And then we go look, what was f prime of 1? F prime of 1 was 2. So, again, these are created so that I have just a limited table that I need. But the idea is, I hope, making sense that like you can only do one derivative at a time. It's the outer function, then multiply by the inner function. And if you had like a series of chains, I'm almost thinking like my mind went to those like nested Russian wooden dolls. Like every doll that you remove needs its derivative. So a complicated thing, which we'll see in the next video, needs a chain for every inner function. Okay, last one on 9 for this table of values. Last one we'll take a look at on this particular video. It says find q of x to be f of 2x squared, find q prime of 1. So again, cover up what's inside. I don't care what's inside, whether it's a function or elephant or who knows. You have to do the outer function first. So the derivative of the outer function would be f prime of that thing. And again, one more time, what was that thing? Nope, I'm just going to have to practice this all weekend long. There it is. That thing was 2x squared. So we put in 2x squared. Then immediately afterwards, we multiply by the derivative of 2x squared, which is 4x. So this is sort of like a hybrid. Some of it is function notation, some of it is in algebra, but it doesn't matter what you call it. You do each of the derivatives. So then we put in -1 into the spaces. So this is f prime of, well, -1 squared is 1 times 2 is 2 times 4 times -1, which is -4. So then I have -4 times f prime of 2, and f prime of 2 was 3. Okay, so I actually like these little problems. I think they're kind of like little puzzles. And you will see them on the AP exam. So that translates into, you'll see them in Mr. Brown's AP class as well. Okay, so process, look at, see if you have questions. If not, we'll finish up the note sheet on the next video.